table shows values of the variables x and y. The relationship between x and y is thought to be of the form y equals ae to the bx, where a and b are constants. We want to transform the relationship into a straight line. Well, I can do that by using logs, and I'm going to use logs to the base e, natural logs. So ln y is going to be ln ae to the bx. So that would give me ln y is ln a plus ln e to the bx. And that would give me ln y is ln a plus bx ln e. And of course ln e is 1. So ln y is ln a plus bx. So that's straight line form. So it looks what I need to do is plot a graph of ln y against x. So that's part 2, which is plotting a suitable graph. So we're going to need values of ln y, and so I'm going to bring in the calculator to do that. So we want ln 736 to start with. That gives me 6.60. And then ln 271. So just wondering what I did with the calculator. There it is. Ln 271. That's 5.60. Then ln 100. It's 4.61. Ln 37. That's 3.61. And ln 13. And that's 2.56. Okay, so we need to plot the graph down here. And let's just make that a bit smaller so that we can get it on the screen. So the y-axis needs to go up to 6.6. So I could do that as 1, 2, 3, 4, 5, 6. That would do nicely. So we'll have ln y in this direction, and we'll have x in this direction. What are my x values? Up to 10. So I think across here we're going to have to go 2, 4, 6, 8, 10. And then up here we're going to go 1, 2, 3, 4, 5, 6, and 7. Okay, so our first point is 2, 6.6. So 2 and 6.6. And then we have 4 and 5.6. And then it was 6 and 4.6. And then 8 and 3.61. And finally 10 and 2.56. And pretty much we can stick a straight line through those. So probably something like that. Well, that goes above my graph. I think looking at all the y values we have, we can estimate that the intercept there is around 7.6. And the fact it's linear shows that this relationship is correct. So use the graph to find the value of A and the value of B. Well, looking back here, B is going to be the gradient of this line, and ln A is the intercept. So we already discussed the ln A. So ln A was, we said 7.6, and then we want the gradient of the line as well. So if we go across and down, we know that this has gone down 2 essentially, and while it's gone across 4, so B is going to be negative 2 over 4, which is negative half. So we'll say here that B equals negative half. We might just say C graph there because we did the working up above. And ln A is 7.6, which means A is equal to E to the 7.6. So E to the 7.6, which is 1998 to the nearest whole number. So we want to estimate the value of x when y is 500. Well, the relationship was of this form: y equals AE to the BX. So y equals AE to the BX. So we can now say that y is equal to 1998 e to the negative half x. So I'm actually going to do this bit down here first because it's the easiest one to do. Estimate the value of y when x is 5. So y is going to be 1998 multiplied by e to the negative 2.5, half of 5. So that's going to be pretty easy. So 1998 times e to the negative 2.5. So that's 164.0. Let's just say 164. In fact, let's make that an approximate sign. And then find the value of x when y is 500. So 500 is equal to 1998 e to the negative half x. So e to the negative half x is going to be 500 over 1998. So negative a half x is going to be the ln of that. I probably should have used the form that was already in ln form. So x is going to be negative 2 times ln 500 over 1998. So we can calculate that. So we have negative 2 multiplied by the natural log of 500 over 1998. And that's 2.77 to 3 significant figures.